Hello students, welcome back. Let's go and solve the next question. The next question says, study the data given below showing the focal length of three concave mirrors A, B and C and the respective distances of objects placed in front of the mirrors. So here we have three mirrors A, B and C having their respective focal lengths, and there are objects placed at different distances from the pole of these mirrors. We have to analyze this data and solve the questions. What are the questions? In which of the above cases the mirror will form a diminished image of the object? Justify your answer. List two properties of the image formed in case 2. And what is the nature and size of the image formed by mirror C? Draw a ray diagram to justify your answer. So we have to draw the ray diagram. So let's understand this table. So in the first case, the focal length of the mirror is given as 20 centimeter and the object is placed at a distance of 45 centimeter. That means if the focal length is 20 centimeter, then the radius of curvature will be 40 centimeter. Now in this case, the object is placed at a distance of 45 centimeter. That means the object is placed beyond C, right? Object is placed beyond C. Now in the second case, the focal length is given 15 centimeter and the object is placed at 30 centimeter. So that means the object is placed at C. So the object is lying at the center of curvature because focal length is 15. So radius of curvature will be 30. So the object is at the radius of curvature, that is object is at C. In the third case, the focal length is 30 centimeter, but the object is placed at a distance of 20 centimeter from the pole. That means object is between F and P. That is, the object is lying between focus and the pole. Now let's see the ray diagrams corresponding to these three cases for a concave mirror. Now here are the three concave mirrors A, B and C, and now let's understand these data in these concave mirrors. For the mirror A, the focal length is 20 centimeter and the object distance is 45 centimeter. So this is the focal length, that is 20 centimeter. So our radius of curvature will be 40 centimeter. Now the object is placed beyond C. So this is our object distance U, which is 45 centimeter. Now if we look at the ray diagrams, one ray goes parallel to the principal axis. After reflection, it passes through the focus. Another ray passes through the center of curvature and goes away undeviated. So these two rays meet at this point, and here is the image which is formed, and the image is a real and inverted image. It lies between C and F and it's diminished or reduced in size. So this is our case 1. In case 2, the focal length is 15 centimeter, the object distance is 30 centimeter. That means the focal length is 15, so our radius of curvature will be 30 centimeter. So the object is placed at the center of curvature. So now let's draw the ray diagram. So one ray goes parallel to the principal axis. After reflection, it passes through the focus. Another ray passes through the focus. After reflection, it goes parallel to the principal axis. These two rays meet at this point, and here is the image which is formed. Now in this case, the image is formed at the center of curvature. It's a real and inverted image, and it's of the same size as that of the object. So this is case number 2. Now in the third case, the focal length is 30 centimeter. The object distance is 20 centimeter. Now this is the focal length, which is 30 centimeter. The object is placed at a distance less than that of the focal length. That is, the object lies in between focus and pole. That is at a distance of 20 centimeter. Now the ray diagrams will be one ray goes and incidents at the pole and it reflects back, making the angle of incidence is equal to angle of reflection. That means in what angle it was incident on the pole, it will get reflected along the same angle. Another ray appears to pass through the center of curvature. So it incidents and it reflects back along the same direction. Now these two rays are diverging rays. So in order to get the image, we have to retrace these two rays backwards. So on retracing them backwards, we see that these two rays meet at this point, and here is the image which is formed. Now the image is a virtual image, it's erect image, and it's formed behind the mirror, and the image is a magnified image. So these are the characteristics of the images which are formed in these three cases. Now let's solve the questions. First question says, in which of the above cases the mirror will form a diminished image of the object? Justify your answer. So mirror A will form a diminished image of the object placed beyond the center of curvature. Now list any two properties of the image formed in case 2. So now the object and the image lies at the same point. So the image characteristics are, the image is formed at C and the image is of same size as that of the object. So these are the two characteristics of the image formed in case 2. Now the third question is, what is the nature and size of the image formed by mirror C? Draw a ray diagram to justify your answer. So this is the ray diagram that we have already drawn. Now let's write down what is the nature and size of the image. The image is virtual and erect. The image is formed behind the mirror, as you can see over here. Then the image is magnified, that it's an enlarged image. So these are the answers to this question. Now whenever you get these type of questions, to be able to solve them, you must be very thorough with the ray diagrams. Then it will be very easy for you to solve these types of questions. So I hope you have understood the solution to this question. If you found this video helpful, please like it, share it with your friends and subscribe to the channel. Thanks for watching. Bye-bye.
Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I have shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.